The first place in space that we will talk about is Sol. A mission to Sol isn't quite the classic image of landing and planting a flag for obvious reasons. Missions to Sol are really missions studying Sol from a safe distance in orbit around it. Let's start with government agencies. NASA has a huge list of Sol studying space probes, more than any other agency. One such space probe, SOHO, is a mission that is celebrating its 23rd birthday today. This probe orbits around Earth's L1 point, a perfect spot for constant observation of Sol with easy signal relay with Earth. The reason that it is not directly on the L1 point is so that Sol doesn't interfere with its communication with Earth. After 23 years of operation, SOHO has learned a thing or two. Chiefly, solar storm predictions are more accurate now, and through study of said storms, astronauts and electric grids can be better prepared for these events. Ironically, while SOHO's purpose is for science and discovery, the main purpose of NOAA's DISCOVR probe, launched in 2015, is to warn people on Earth of coronal mass ejections. DISCOVR, sitting at Earth's L1 point, receives solar wind about an hour before it hits Earth. Also, using other studies of Sol, DISCOVR can make predictions further into the future about solar weather. With these two functions, people on Earth can have time to prevent damage from solar events. Another mission of NASA actually consists of two probes. This is the STEREO mission. The two probes, STEREO A and B, are at Earth's L4 and L5 points with Sol. The advantage of having two identical spacecrafts spread far apart is that the two different angles allow for a three-dimensional rather than flat view of events on Sol. The other space probes render flatter images, and while the third dimension can be implied most of the time, the duo of space probes makes it plain and simple to see exactly what is going on with Sol. The final NASA probe is one near the beginning of its mission, the Parker Solar Probe. Unlike the other Sol-observing space probes, the Parker Solar Probe is much closer to Sol than Earth's Lagrange points. The Parker Solar Probe is on a highly elliptical path around Sol. This path will let it get close enough to study various aspects of Sol that we haven't been able to study before. The probe will skim through the very highest parts of Sol's atmosphere. Next is the Hinode probe, a mission led by the Japanese Space Agency, yet is a collaboration between the European and American space agencies as well. Hinode was put in low Earth orbit, 600 kilometers above Earth. This probe has a 50-centimeter telescope, the largest space telescope dedicated to observing Sol. With this telescope, Hinode can view features of Sol down to the scale of 175 kilometers. That might not seem like great resolution, but that is the best we have yet, and considering that Sol is 1.4 million kilometers wide, that is pretty good. Another probe is CNES's PICARD probe. This Sol-observing probe analyzes the specifics of how Sol operates, from getting an exact measure for its rotation rate to observing the centrifugal force flattening the poles and expanding the equator to analyzing Sol's interior. PICARD has gathered a lot of information. All of this information helps scientists further understand Sol and how it affects Earth's weather. In the near future, within a few years, the Indian Space Agency plans to launch the solar probe Aditya-1. This will be another probe at Earth's L1 point, with a similar purpose to the other solar probes, to study Sol and warn of coronal mass ejections. How about the private sector? Private companies are necessarily motivated by profits, and not just scientific exploration. Unlike a government agency that has a nearly guaranteed source of funds, even if they are just studying and observing things in space, private companies need to make money off of their ventures in space. Otherwise, they will go out of business. While some of these companies have eccentric owners that use the profits of their company to fund less profitable but equally important missions in space, none of these companies are studying Sol. That was the outlook and present state of the study of Sol. Right now, we are mainly studying Sol so that we can protect ourselves from possibly catastrophic events that Sol could cause. The studies of how Sol operates, its 11-year magnetic field cycle, and the properties of its different layers are important to understand, both to further scientific discovery and once again to protect ourselves from Sol. Next time, we will look at the study of Mercury.